Okay, introduction to limits. So what is a limit? Well, a limit is basically, this is just a real simple definition, it's the intended height of a function. So it's where the height is or where it should be if it does not actually exist there. And there's lots of different ways we can calculate the limit. We could do the numerical approach, which we construct a table of values. We could do the graphical approach by actually graphing and just visually seeing where does it look like the height is at for any given x value. We can also use a graphing calculator to do this. Or the analytical approach, and this uses algebra or calculus. We're going to do all of these, but of course primarily we'll end up doing this method. So here's just a different idea. Here's a visual representation of 3 different ways. See, this is a table, and so you can look at this table and you could see what does it look like the height is when we get really, really close to 2. Actually, I think it's actually really, really close to 3. I think there's a couple typos here real quick. One, I think that this actually should be positive and that this should be 3.01. And so let's ask ourselves, what is the limit as we get closer and closer to 3? Now this little plus means 3 from the right. So this is actually asking if we came from the positive direction. So if we came from this side, as we get closer and closer to 3, we can see that this is approaching, 5.06. So maybe even really close to 5. But if you come from the other side, if this said 3 with a negative symbol, you might also see this sometimes. X approaches 3, and then this means from the left, from the negative side. You'd see, look, it also looks like it's approaching 5.00. So it's somewhere between, at 3, we could say this function is somewhere between 5.006 and 5.06. So something a little bit more than 5. We'll play with that more. On this one, you got the graphical approach. So let's just say real quick, like 3 is right here. And let's say we're trying to find the limit as it approaches 3. We're just going to look at this graph and see, well, where does it appear to be? Where does the height appear to be? And it would be like right here, right? So whatever that value is, that would be the limit, because it appears to be hitting that value right there, right when x is 3. Okay, and the other way is the analytical approach, and we'll talk about that in future videos. But that involves some algebra skills and maybe some calculus. All right, let's go to the next page. Okay, so a basic limit statement looks something like this. The limit as x approaches 2, and then there could just be f of x there, or you could have the actual function written out, whatever f of x is equal to, and this one says it equals 4. So we know the limit at x is 2, as x approaches 2 is 4. That just means that when x is 2, this function has an intended height of 4. It could have a hole there, it could be missing some information, but we could say that the height itself would be 4 if it was there. That's all that means. So all we're going to do here is we're just going to write this limit, write each limit as a basic limit statement. So if I was to do this, write each limit as a basic limit statement. So there's a few different ways I could write this, but I could just say, I'm saying as x approaches 2, so I could say the limit as x approaches 2 of what? Well, I'm talking about this function. So I could put either f of x here or x cubed. I'm going to put x cubed. And what would that equal? Well, this is really simple, because one of the things that ways we can evaluate limits really easily is we could just plug in the x value that we're approaching and see if we get an answer. If we do, we're pretty much done. So what is 2 to the 3rd power? Well, 2 to the 3rd power is 8, so this is just 8. That's it. So we could say the limit as x approaches 2 of x cubed is 8. All there is to it. So we did that by plugging it in, but let's do it now graphically and see. So it says graph and find what the limit is equal to. We're going to graph this same function. Now maybe you remember what this graph looks like, and if so, you can just sketch it real quick. But let's say you didn't for whatever reason, we could make a quick little table. And we could say, hey, we got -3, -2, -1, 0, 1, 2, 3, and we could get a sketch of this graph by just filling in this table really quickly. So what would it be? -3 cubed? Well, that's -27 negative 8, negative 1, 0, positive 1, positive 8, positive 27. So, oops, meant to put a 3 there. So I don't think we really need to include these values. These are going to be off the charts. But the other values we could include pretty easily. Well, let's do this. Make that 1. And let's just call this negative 8. Positive 8. So we can kind of get an idea what this thing looks like. So we know that at negative 2, it's at negative 8. At negative 1, it's at negative 1. And at 0, it's at 0. At positive 1, it's at positive 1. At 2, it's at 8. And so this function looks something like that. Now, I want to emphasize this. Notice, if I didn't remember what this function looked like, all I have to do to get a quick sketch of it is create a table of x values, plug them into the function. All I did is plug in these numbers into this function, and it gave me heights, or y values. And I just plotted those points on my graph, x, y, x, y, x, y, and then I have a graph. I have a really good sketch of that graph. You can do that for any function. Literally any function. And this is a common misunderstanding of functions. You don't have to remember what every graph looks like. You can always create a table and plot those values. Sometimes it takes a little bit longer, but you can always do that. So as we look at this thing, what we're really asking is, hey, what is the height as we approach 2 here? So here's 2. So what does the height appear to be? And let's just imagine we're approaching from both sides. Well, as you go along this curve and you get closer and closer to the x value of 2, what do you get closer and closer to in height? Well, you get closer and closer to 8, right? So as we come from the left, we get closer and closer to a height of 8. As we come from the right, we get closer and closer to a height of 8. So again, that means that the limit is 8. That's all that we're talking about when we're talking about a limit. Let's go on to the next. This one says solve analytically. We kind of already did this. When they ask to solve analytically, the first step is always to just plug it in. Plug in the value that x is approaching. So this would just be 2 cubed, and we of course know that 2 cubed is 8, and there we go. We have solved it analytically. That's all there is to that one. Okay, that's it for the introduction to limits. We'll talk about it more in the next video.